Welcome back, chemistry fans. Today, what we are going to do is do the Unit 4 exam. We're going to go over the solutions to this. So let's go ahead, share our screen. And you can start to see, hopefully, a little bit about what we're trying to accomplish here. Let's flip back a few slides. One more slide. And here we go. So in this, we are supposed to do multiple tasks simultaneously. We are to predict what the products are and determine what the type of reaction, balance all the compounds, balance what the reaction is as well. So all of these skills all at once. How do I know what type of reaction this is? Actually, you start with that, even though it is listed as Part D. What we need to understand is that this is one material by itself, and that means that it is going to break apart into pieces. And we could break this up into two pieces if you wanted to, but the combinations are a little bit different, and I'd be willing to entertain some other options that if you came up with them, but this is the most reasonable answer. And the reason why it would not be ALI is because we already have that to start with, and that's the only way in which that can exist. So I can't have just ALI. It wouldn't balance its charges. So we would have aluminum by itself as a solid, and then we would have iodine, which is also at room temperature. It is a solid. Now it's not balanced at this point, so we'd have to double, and triple this one to give us the 6 iodines, to give us the 6 total iodines. Everything is balanced at this point. Okay, and why is I2 by itself, or why is it diatomic? By that very nature of what it is material-wise. All right, on number 2, we had to recognize that this is a single replacement, and this element here is a metal, so it's going to switch places with the other metal. So what we could do is work backwards and figure out that the charge of the dichromate is -2, the charge of the titanium is +3. But that really didn't matter because the titanium is going to be by itself. What it's important for is the calcium dichromate, is that it is going to balance out because that's a +2 and a -2. Okay, so with that said, I've got in the initial reactants, I've got 3 of the dichromates. So that means that I'm going to have to make 3 of these, meaning that I have to have 3 of these, meaning that I'm going to have 2 of those. Titanium is not diatomic. And we can't just simply bring these subscripts down here because it's not balanced as a product. All right, number 3. This one does not tell you what the elements are per se by symbol, so you have to translate this. So I've got gallium, which is not a diatomic, it's a monatomic element, but I do have nitrogen, which is diatomic, and you had to recognize that. So what it's going to form is GAN. They have a +3, -3, but it's not balanced. So I'm going to have to put a 2 in front and a 2 in front to give us this. We can't just simply, again, put the coefficients over here. It's not balanced that way. Gallium has a +3, nitrogen has a -3. I get those off of a periodic table with the charges available to you, which you had available to you during the exam. All right, number 4. Move me back into the picture. All right, here we go with number 4, I believe, is the first one here. And so this time we have a double replacement reaction. How do I know it's a double replacement reaction? Because there are no materials by themselves. So I'm going to be switching the 2 cations, not metals in this case, because hydrogen is not a metal. And so what you have to recognize is when I put H and OH together, it's going to make H2O. And the other material is going to be the vanadium sulfite, VSO3. But now I'm going to have to figure out what are the charges of these materials so that I can balance the compound correctly. So this one, if I move the charge backwards, has a +5, and sulfite off of your polyatomic list has a charge of -2. So now I've got a +5 and a -2. Those 2 charges are in the air like they just don't care. I'm going to have to crisscross them down and throw them to the ground. Okay, now I have my products balanced, the formulas, but I don't have the reaction balance. So I'm going to have to put a 2 in front of this vanadium because there are 2 on the products. I'm going to have to put a 5 in front for this sulfite. Now, what that did is it made 10 hydrogens and it made 10 hydroxides. So if I bring those together, what I should have over here is a total of, let's see, 10 hydrogens. So I should have a 10 right there because that's 10 total hydrogens and 10 total hydroxides that come together to make 10 water. So 5, 2, 10, 1 is your answer on that. All right, number 5. This one is a combustion. And how do I know it's a combustion? Because there's an oxygen by itself on the reactant side. What it's going to make is carbon dioxide and water. Those are the products of a combustion. Now, to balance this, I've got 9 carbons. I got 9 carbons. I got 18 hydrogens, so I'm going to need to put a 9 right here to give me the 18 hydrogens. Now, what I've got total here is 18 plus 9, which is equal to 27. 27 cut in half is 13.5. This is balanced, but we can't leave a decimal. So my final answer needed to be 2, 27, 18, and 18. Okay. The last of these types of reactions is down here, and it is also a double replacement reaction. And so what we have is, again, a listing of the elements names, but not necessarily what their formulas are. So you had to convert this. So I got lead to nitrate +2, and the nitrate is a -1. Those would have been recoverable from your pink polyatomic ion sheet. So what we get here as our product is that I need to put a 2, as our reactants, I need to put a 2 there to balance those charges. I need to put a 2 right there to balance those charges. Now, because it's a double replacement, the metals are going to switch places. So I've got PbCO3, and I have CrNO3. Now they stay with their original charges, +2, -2. +4, -1 means I need a 4 down there. So this is not balanced. So I'm going to have to put a 2 in front of the Pb because I've got, in front of the nitrate because I need 4 of the nitrates. Well, that means now I have 2 of the lead, so I got to put a 2 there, but that's okay because it also needed 2 of the carbonates to balance out right here. I only have 1 of the chromiums. So everything is balanced. That's the end of this one as a double replacement. Okay, so now we are moving on to questions 7 and 8, which are the more complex ones where we have to write our net ionic equations. Now, again, you're having to do the exact same process we had to before. I've got solid silver, Ag, 1 is its charge, iodide. Iodide has a charge of -1, so it's solid, plus magnesium nitrate. Now it's a 2 because the charge on magnesium is +2, the charge on nitrate is -1. What's it going to do? It's a double replacement reaction, so it's going to switch partners. I have Ag, and these are aqueous because everything it states in the problem that is not told to you is assumed to be aqueous. I've got silver, and I'm going to have nitrate come together over here. And I'm going to have magnesium, and I'm going to have iodine. Now, because of their original charges, it's going to be MgI2. All of these are aqueous, aqueous. Now, the complete ionic, how we do that is that you have to now separate, and here's where it gets to be a pain. But you do not separate the solids. One of the simple mistakes that many of you made. So I'd have Mg +2 aqueous plus NO3 -1 aqueous produces Ag +1 aqueous plus NO3 -1 aqueous plus Mg +2 aqueous plus 2 iodines. Here is another mistake area that many of you made. You left this as I2. It needs to be 2 iodines. They separate into separate iodine ions whenever it is aqueous. The only time they stay together in their original format and don't separate completely is when they are a polyatomic ion or when they are a solid over here. Now what we get to do on the next step is we get to cancel out like terms. Magnesium is the same on both sides. It gets canceled out. The nitrate is the same on both sides. It gets canceled out. Everything else is left. So the net ionic equation is AgI solid producing Ag ion aqueous plus 2 iodines. So this needed to be balanced actually. 2 iodine ions that are aqueous. Okay. That's your first answer. That's our net ionic equation. Let's do another one just like it for number 8. So this one is solid nickel. So again, the nickel means the solid tells you it's going to have the little S after it. +2 is its charge, phosphate. Look on your polyatomic charges, and you'll notice that it is -3, meaning that those little charges need to be crossed down. Plus sodium perchlorate. So I've got sodium +1 perchlorate is ClO4. It has a charge of -1. So they've already balanced, but it is aqueous. It's a double replacement reaction. It is going to switch places. So I'm going to have nickel 3 nickel 3 perchlorate. Because of their charges, I'm going to need 3 of those. 2 of those. Because the nickel has a charge +2. It's the sodium that's going to combine with the phosphate that will carry the 3 because the charge of the phosphate is -3. Now I got to balance this. So I'm going to put a 3 in front here to balance the sodiums. I need to put, actually, I got to put a 6 is how this is going to work out. So 6 right there, a 2 right there, a 3 right there, because I have 3 of these nickels. And so now I have 3 nickels. I have 6 perchlorates, 6 perchlorates, 6 sodiums, 6 sodiums. I only need 1 phosphate. Oh, I have 2 phosphates. So I have 2 phosphates and 3 nickels. So everything is balanced. These are aqueous, both of these. Now we're going to write this as a complete ionic, and this is where it gets really, really messy. Do not separate the solid. Do not separate the solid. But you must separate all of the other elements into their simple ions. Polyatomics stay separate. You must include the state of matter. So 3 nickels, aqueous, 6 of the perchlorates, and we must put the charges on each one of these. Oh my goodness, so many little details that could go wrong if you're not paying attention. 6 of the sodiums, +1 aqueous, and 2 of the phosphates, -3 aqueous. Okay, now we cancel out like terms. Sodium on both sides is aqueous. It gets canceled out. Chlorate, perchlorate on both sides, the same. So it gets canceled out. So what we're left with is the net ionic equation. Nickel 3, phosphate 2 solid produces 3 nickel ions that are aqueous plus 2 phosphate ions that are aqueous. All right. This is everything that you should have been able to do on your test. Thank you very much for your time. I will talk with you again very soon. Hopefully this helps you understand where your mistakes may be, what you need to practice to become a master of the content. Thank you very kindly. Good day.